These are genetic as well as pharmaceutical approaches to reducing the amount of cancer. The body has enzymes, like CYP enzymes, that process what are called xenobiotics. Some of the xenobiotics are associated with carcinogenesis. Let's look at a particular xenobiotic. There are other xenobiotics that are more carcinogenic, yet polychlorinated biphenyls are known to be carcinogenic. Now, let's say there are three enzyme systems at the body which metabolize or convert polychlorinated phenols to other molecules downstream. There's one that divides the biphenol molecule into two parts, which would result in the creation of two chlorinated phenols. And then there's an enzyme that removes chlorine from polychlorinated biphenyls, which would result with the creation of a biphenol molecule. Now, let's say that the biphenol molecule is more carcinogenic than the chlorinated phenols. We can see then that increasing the amount of the naturally occurring enzyme that divided a biphenol would more rapidly process the xenobiotic, thus reducing the cancer risk while also removing the downstream products which were carcinogenic. Now, there are a few approaches to this. There's the genetic approach of giving people the genes to produce those enzymes which are shown to be most effective at producing downstream chemicals which are absent harm. Then there's also the pharmaceutical approach where another medication which is beneficial, perhaps a longevity medication or a nootropic, which causes the upregulation of those enzyme systems which also are the most benevolent at processing xenobiotics. Thus, the person taking their longevity medication or their nootropic would also be saturating, then upregulating the most beneficial CYP enzymes, which would make preferential versions of the downstream molecules, thus reducing cancer.